Welcome everyone to a deep dive in something really fundamental, AI agents. We bump into AI constantly, voice assistants, those recommendations you get online. But what's really going on underneath? What's the sort of architecture letting these systems think and act? Today we're pulling back the curtain on AI agents. These are the foundational intelligences behind so many smart systems. We've dug into some great material, specifically AI agents, function and applications, to bring you this deep dive. Our mission today, to give you a really solid grasp of these autonomous entities, how they work, and the huge impact they're having. By the end, you won't just get how your Alexa or Siri works. You'll understand the bigger picture, the implications of systems perceiving, deciding, and acting on their own. It's shaping everything. So let's start right at the beginning. What actually is an AI agent?
Right, exactly. So at its most basic level, an AI agent is an autonomous entity. It's designed specifically to perceive its environment, make decisions, hopefully informed ones based on what it perceives, and then crucially take action in that environment to achieve some goals it has. They really are the active core of, well, many of the modern AI systems you're interacting with, maybe without even realizing it.
Okay, so if they're interacting with the world, they need ways to sense it and ways to act back, right?
Yeah.
What gives them their senses in their hands, so
Yeah.
to speak?
Yeah, that's a good way to put it. They bridge the digital and the physical. So first you have sensors, sometimes called perceptors. This is how the agent gets information from the environment. Think, cameras for vision, microphones for sound, and maybe even tactile sensors, or just streams of digital data.
Okay, the inputs.
Exactly. Then second, you have effectors or actuators. These are the outputs, how they actually do things in the environment. It could be a robotic arm moving, motors turning wheels, displaying information on a screen, sending commands over a network. Lots of possibilities.
Right.
Right? And the key piece tying it all together is the agent function. This is the core, the brain, if you like, that maps the perceptions coming in from the sensors to the actions going out through the effectors. And this function, it's not always simple. It can be implemented through standard programs, sure, but also sophisticated neural networks, complex rule-based systems.
So that's where the intelligence really sits, in how it makes that connection.
That's right. That mapping, that agent function, is where the agent's specific intelligence lies, how it turns raw data into, hopefully, smart actions.
So we've got the inputs, the outputs, the processing core. But what makes them more than just fancy machines? What are the defining characteristics that make us call something an AI agent?
Good question. Beyond just the components, there are several key characteristics. First, and maybe most obviously, autonomy. They can operate without needing constant human hand-holding. They make choices. Second, perception, which we touched on, that ability to gather information about their surroundings through the sensors. Then there's reflection or reasoning. This is how they process those perceptions, make sense of them, and figure out what to do next.
The thinking part.
The thinking part, exactly. Followed by action, the capacity to actually execute those decisions and affect the environment. And finally, there's a really crucial one, rationality. A rational agent isn't just any agent. It's one that acts to maximize its performance measure, given what it perceives. It's always trying to do the best thing according to its goals and knowledge.
Ah, right. So rationality means it's trying to achieve its goal in the most effective way possible based on the information it has.
Precisely.
That makes sense for something like a navigation app. It's not just seeing traffic, it's constantly recalculating the best route, the optimal one to get you there fastest or shortest or whatever its performance measure is. It's trying to be smart about it.
Exactly. That's how you observe it acting smartly. It's exhibiting rational behavior towards its goal.
Okay, so we have the parts, we have the characteristics like rationality.
Mm-hmm.
How does it all actually work together? Is it like a constant loop? How do they operate moment by moment?
Yeah, it's very much a continuous loop. It's often called the perception-action cycle. It's fundamental. It starts, naturally, with perception. The agent gets information via its sensors. Then comes analysis. Those raw perceptions are processed, interpreted, given meaning by the agent's internal function. Based on that analysis and remembering its objectives, the agent moves to decision. It figures out the most appropriate action to take right now.
Okay.
And finally, action. The chosen action is executed via the effectors. And this is key. That action then changes the environment, which in turn affects the next perception.
Ah, so the action feeds back into the next perception.
Exactly. The cycle repeats continuously. That's what makes them dynamic. They're constantly sensing, thinking, acting, sensing the results of their actions, thinking again. It's why a self-driving car isn't just reacting to one thing. It's in this constant flow, this cycle, dealing with a dynamic world.
That cycle explains a lot. But you mentioned rationality and goals. Does that mean all AI agents are super complex thinking machines? Or is there like a scale of complexity? Can you walk us through the different types?
Oh, absolutely. There's definitely a spectrum. It's not all one thing. We can break them down. The simplest ones are called simple reflex agents. These guys act only based on the current perception. No history, no memory of what happened before, no internal model of the world.
Look at a knee-jerk reaction.
Pretty much. A classic example is a simple thermostat. Temperature drops below X, turn on heat. Temperature goes above Y, turn off. It's just reacting to the immediate input.
Okay, basic stimulus response.
Exactly. Now step up from that, you have model-based reflex agents. These are smarter because they do maintain an internal state, a kind of model of the world. This model gets updated based on past perceptions, and it allows them to handle situations where the current perception alone isn't enough. They can reason about things they can't directly see right now.
Ah, so they have some memory, some context.
Right. Think about an autonomous driving agent. It needs a model of the road where other cars likely are, even if they're temporarily hidden, traffic rules. That model helps it anticipate and make better decisions than just reacting to what's immediately visible.
Makes sense. What's next?
Next up are goal-based agents. Now we're getting into planning. These agents still use a world model, but they also have explicit information about their goals, desired states of the world. They choose actions that they predict will lead them towards achieving those goals. This often involves thinking ahead, searching through possibilities.
Like planning a route on a map.
Or a great example is a chess-playing agent. It's not just making a good current move, it's planning sequences of moves, thinking several steps ahead, aiming for that checkmate goal state.
Okay, planning towards a specific outcome.
Then, even more sophisticated, you have utility-based agents. Goals are sometimes not enough, especially if there are conflicting goals or uncertainty. A utility-based agent doesn't just want to reach a goal, it wants to reach the best state. It uses a utility function that assigns a score, a level of desirability to different states. It chooses the action that leads to the state with the highest expected utility. It's about maximizing happiness or satisfaction in a way.
So it weighs pros and cons, like this route is faster but riskier, that one is slower but safer.
Exactly. A stock trading agent is a perfect example. It's not just about making any profit, a goal, but about maximizing the expected return while considering the risk balancing factors based on its utility function.
Right, optimizing for the best outcome overall.
Precisely. And finally, we get to learning agents. These are really interesting because they can improve their performance over time with experience. They have a learning component that actually modifies the agent's core function. There's usually a critic element that evaluates how well the agent is doing based on some feedback, and a problem generator that might suggest new exploratory actions to take to learn more.
Ah, so these are the ones that get smarter.
Yes. Recommendation systems are a prime example. The more you interact, the better they get at suggesting things you'll like. Voice recognition systems, too, they learn and adapt to your voice and nuances over time.
Wow, okay. That progression makes a lot of sense. From simple reaction all the way to learning and adapting. It really puts the tech we use into perspective. You see how even something simple might be based on these ideas and how it scales up to, a sophisticated recommendation engine or even parts of autonomous systems. So practically speaking, then, where do we actually encounter these agents? You've given examples, but just how widespread are they? Are they mostly behind the scenes?
Oh, they are everywhere, truly ubiquitous. You find them, obviously, in autonomous robots. Think self-driving cars, delivery drones, those robots you see in modern warehouses or factories.
Yeah, the physical ones.
Right. But also in the virtual world. In video games, those non-player characters, NPCs that seem intelligent, often driven by agent architectures to make the game more dynamic. Recommendation systems are a massive area. Netflix, Amazon, Spotify, suggesting what you might like next. Those are learning agents working hard.
Definitely use those.
Your virtual assistants, Siri, Google Assistant, Alexa, they're classic examples of agents perceiving your voice, understanding intent, and acting on it, like playing music or setting a timer. And then there are less visible but critical areas. Cybersecurity uses agents for intrusion detection, monitoring networks for suspicious patterns, and sometimes even automatically responding to threats.
Wow.
In logistics, they're optimizing delivery routes, managing warehouse inventory, making supply chains much more efficient, and even in healthcare, you have AI agents assisting with diagnostics by analyzing medical images or monitoring patient vital signs and alerting doctors to potential issues.
It's incredible. They really are woven into the fabric of modern life, often completely behind the scenes, just making things work.
Yeah.
or suggesting my next movie. But like any powerful technology, it can't be all upsides, right? When we talk about systems making decisions autonomously, what are the benefits, but also what are the challenges or risks we need to consider?
Absolutely. It's a balance. The advantages are pretty clear. Huge gains in automation. Agents can handle repetitive, tedious, or even highly complex tasks tirelessly,
Yeah.
204/7, without direct human oversight.
Frees up humans for other things.
It's exactly. This leads to massive improvements in efficiency. They can optimize processes, reduce waste, speed things up dramatically, and often cut down on errors. There's also precision. AI agents can process enormous amounts of data and make very fine-grained, informed decisions much faster and sometimes more accurately than humans can, especially with complex data sets.
Right.
And as we saw with learning agents, there's adaptability. Some agents have this remarkable capacity to learn from experience and adjust their behavior to changing environments or new information.
Okay, those are compelling benefits. Automation, efficiency, precision, adaptability. But what's on the other side of the coin? What are the hurdles?
The challenges are definitely significant, and they're things researchers and developers grapple with constantly. One major one is simply design complexity. Building agents that are truly robust, reliable, and perform correctly in all the unpredictable situations the real world throws at them. It's incredibly difficult engineering.
Things can always go wrong in unexpected ways.
Precisely. Then there are huge considerations around ethics and security. This is critical. How do we ensure agents act ethically, especially in high-stakes situations like autonomous driving or medical diagnosis? How do we prevent them from being hacked or misused? Securing these autonomous systems is a major ongoing challenge. Embedding ethical guidelines into code is, well, it's a profound problem.
Yeah, the trolley problem, but for code.
Kind of, yeah. And related to that is explainability, often called the black box problem. Especially with very complex agents like deep neural networks, it can be extremely hard to understand why an agent made a specific decision. This lack of transparency can be a real barrier to trust, to debugging when things go wrong, and to ensuring accountability.
If you don't know why it did something, how can you fix it or trust it next time?
Exactly. And finally, there's uncertainty management. The real world is messy, uncertain, and always changing. Agents need sophisticated ways to handle incomplete information, sensor noise, unpredictable events. Designing them to cope effectively with uncertainty is still a big research area. So yeah, this definitely raises important questions. As these systems become more capable and integrated, how do we navigate these challenges? How do we ensure we develop and deploy them responsibly?
Absolutely. It's a conversation we need to keep having. Well, today we've really taken a journey, haven't we? We've gone from the basic building blocks, sensors, effectors, the agent function, through the key characteristics like autonomy and rationality. Explored the whole spectrum of agent types, from simple reflexes up to complex learners, and seen just how widespread their applications are in our daily lives.
And I think it's clear that AI agents aren't just one specific technology. They represent a really powerful way of thinking about and building intelligent systems. Their ability to perceive, reason, and act autonomously is it's fundamental to so much of the digital revolution we're living through. They're pretty much indispensable now.
So here's something to think about as we wrap up. As these AI agents get more and more sophisticated, more integrated into everything we do, and especially considering that challenge of explainability, the black box, what does that really mean for us? For human decision-making, for our relationship with technology? How might our very idea of what constitutes intelligence continue to shift because of these agents? Something to ponder. Keep exploring, keep noticing the agents working, learning, and acting all around you.